You complete the courses, the repository fills up with saved projects, the certificates are stacked right there on the desk. But there is a quiet, lingering realization that checking the final box didn't actually finish the job. You know the vocabulary, you know how to import the libraries and call the models, but when the guide rails are removed and the prompt is blank, can you actually demonstrate your own judgment? Completing a tutorial is a private act of following instructions. Proving your capability is a public act of defending your choices. It is the difference between reading a pristine recipe card and stepping into a chaotic kitchen where ingredients are missing and the pan is already too hot. If we endlessly collect syntax without anchoring it to a real problem, we aren't building a skill set. We are just accumulating noise. There is an urge to prove your worth by building the most complicated machine possible: a massive neural network, a sprawling dashboard, a multi-agent swarm. A true capstone project acts as a physical record of human judgment, the place where technical skill is finally anchored to a specific, defensible decision. A project only earns that title when you can sit down, present your work, and confidently defend every hidden assumption, every missing row of data, and every trade-off you made. A narrow, simple system that can withstand rigorous questioning proves far more capability than a sprawling workflow that falls apart the moment someone asks, "Why did you build it this way?" This diagram shows the progression of data science. We learn foundations, handle uncertainty, move into machine learning, and eventually modern AI. But these steps compress to form a solid foundation for one specific goal: elevating human decision-making. So you arrive at the desk with a massive CSV file, ready to build. We often mistake a clean data set for a finished project, but data is merely the raw material. It requires a defined human gap to give the technology a reason to exist. The real work begins with problem framing. That means identifying the specific human gap, the confusion, the delay, the lost value that needs to be clarified so someone can act. Until you name that specific human need, any code you write is aimless momentum. Once the problem is named, you have to prove your solution is grounded, and that requires drawing a strict boundary between raw data and actual evidence. Numbers in a spreadsheet are just data. Evidence is data that you have interrogated, documented, and bound by its limitations. We structure this using the capstone proof canvas. It acts as a mirror reflecting the architecture of your reasoning, forcing uncomfortable questions before you write code. Who is affected? What evidence matters? What are the failure modes? Who provides human review? Condensing the project onto a single, clear page strips away the technical decoration. It leaves your logic completely naked and open to inspection. There is always a lingering temptation to expand the scope and add more features, but excessive size often acts as a smokescreen for weak thinking. A bridge earns our trust not because it spans a great distance, but because its foundation, its load limits, and its maintenance plans are fully documented and rigorously inspected. The polished, predictable safety of a tutorial environment ends exactly at the border where real-world failure begins. Real-world failure forces a mandatory pause. You have to isolate the broken link, identify why the evidence failed, and manually re-engineer the logic. It's in that specific act of correction, of finding the why behind the break, that the theory finally becomes an installed capability. Slowly, emphasizing the point, an AI system that pretends to know everything is dangerous. A system that explicitly documents its boundaries, its uncertainties, and its limits is wise. Ultimately, the true proof of your capability does not live in the complexity of the tools you deploy. It lives in your willingness to communicate your trade-offs, invite careful inspection, and take responsibility for the final human impact.